On our last vehicle tutorial, we made a very bare bones red car, which was pretty much limited to wheels and steering wheel that moved. This time we're going to get a little more complicated, and we're going to delve into some minimal animation. So what I've done in this case is you can see there's a character inside the car this time. We're going to make a character drive this car. This is a car that's similar to one of the cars that comes with Outerra. Found it on Sketchup and downloaded it, and I'm going to adapt it so that when we use that vehicle, sometimes we can show a character driving it. So when you want to animate anything in Outerra, the thing that is animated has to be separate from the rest of the model. So in this case, we're going to animate the head, so it's separate. We're going to animate all of the wheels. Of course, we've done that in the last time. We're going to animate the arms. You can see the arms can be turned off and on, so that when the steering wheel turns, his arms follow the steering wheel, and his head is going to look from side to side when he drives, if he's turning. So that's not a lot more animation than we did in the past, but it's a stepping stone to being able to animate literally just about anything. Anything that can be broken into pieces can be animated in Outerra. So you can see in our hierarchy this time, we have a few more meshes than we had the last time, but it's still basically the same procedure. So we're going to start by shift-clicking all of our meshes so that we can parent it to the chassis. And the last thing that gets clicked is going to be the parent. And it just so happens that our hierarchy is not in order. So I'm going to jump over chassis and click these arms, because the last thing you click becomes the parent. So click chassis last. Object, parent, object, object. So now we've got everything as a child to chassis. Now we've got to put the manipulators back on each of the elements. So to do that, we one at a time, starting at the bottom going up, we're going to click on one of the meshes, object, transform, origin to geometry, transform, origin to geometry, transform, origin to geometry, transform, origin to geometry. And there's going to be something a little different on the arms. Transform, origin to geometry, steering wheel, transform, origin to geometry, head, transform, origin to geometry, now for the arms, I'm going to hide the windows again. I'm going to click the arm, the left arm here. And if I do origin to geometry, it's going to put the manipulator right about on the wrist, which means that whenever I try to rotate it to follow the steering wheel, it's going to leave the shoulder, and it's going to stay. It's going to rotate about the wrist. So we want the shoulder to be the place that it rotates. So what we're going to do is click where I want it to be, and then object, transform, origin to 3D cursor. And now that will make that the rotating point. Likewise on this side, highlight the right arm, click where I want the rotation to be, put the cursor there, object, transform, origin to 3D cursor. And finally, I want to put the chassis, object, transform. In the case of the chassis, I'm going to put origin to center of mass. That'll make the car more stable in the Outerra environment. So we've got all of these things with their manipulators again, so we can turn Windows back on and export as FBX. Of course, geometry, set the faces for smoothing, gives you much more smooth finish at the end. And that should be all we need Blender for. Control F7, open FBX, and navigate to the file, and in this case it's already open, so click Porsche.fbx, open. Okay, so as we did before, we're going to click on camera, say do not import, lamp, do not import. The steering wheel is going to be animated, so we're going to convert it to bone. The arm is going to be animated, so we're going to convert it to bone. The wheel will be animated, we'll convert it to bone. The windows are not going to be animated, so we'll skip over that. This wheel will be animated, so we'll convert it to bone. This arm will be animated, convert it to bone. The grill will not be animated, so we'll leave it alone. This wheel will be animated, convert it to bone. This wheel will be animated, so we'll convert it to bone, and the head will be animated, so we'll convert it to bone. So you can see you can have a mix of sub-meshes which are animated and some which aren't. Now we click the very top item in the hierarchy, create package, and when this says import complete, close, close, escape, quit. Okay, now here, each time we change this, we have to come back to the object definition file, and in physics, I'm going to type vehicle, and in script, we're going to say Porsche.js, and that's all we need to change here. Also, I like to go through the material file and make sure that the DDS files where they're defined, if there's a texture, is in there correctly. And what I also like to do is wheel UVs. We'll leave that roughness at the default of 498. We will pants, I want them to be a roughness of 1. I want them to be dull. Mirrors, I want them to be shiny, so that would be a 0 roughness. Glass, I want it to have opacity, so I'm going to make the opacity, instead of 1, I want it to be 0.3 on both of these, color and diffuse. And I also want the roughness to be 0. Very smooth for glass. And then for the grill, we'll leave that the defaults. The auto body, the only change we want to make is to make the paint very smooth. So make that a 0 roughness. The logo, we'll leave that the way it is. Brake lights, because that's glass, we'll just change the roughness to 0. We don't want to be able to see through that, because you'll actually be able to see through the car, so we'll leave that opaque. And seats, we want the roughness to be 1. It's the least amount of roughness, or the most amount of roughness. It'll be like a matte finish. For lettering, we'll leave that alone, and fog lights, we'll make that 0 for roughness. That would be smooth as glass. T-shirt, we want that to be 1 for fabric roughness. And chrome, we want it to be very smooth. So that will be 0. And for the interior, we want it to be roughness of 1. For glass, again, we want that to be roughness of 0. This glass is like brake lights or something, so we don't want it to be transparent. We just want it to be shiny. And skin, we'll just leave that the way it is. Hair, we'll leave that the way it is. Headlights, we'll make it shiny. 0. And default was the last one. So those are the changes we need to make to the material file. Now let's look at the script. I've already made some changes to the script, but when you're animating, my convention is to put variables at the top so that you don't have to start making a lot of changes down here. That does add some extra elements to deal with, which might make it more confusing. But we'll look at how I've done it anyway. Once you understand it, you may find easier ways to do it. Okay, so these are the things that we're going to animate. The wheels, and each of these things has to be named exactly like the mesh was named in the model. So my wheel meshes were named wheel underscore front right, front left, right rear, right left, or rear right, rear left rather. The steering wheel, I named steering underscore wheel. The guy's head was named head, and the left arm was arm underscore L, arm underscore R. So right now these are just set up as variables. We also have a variable for head ID, arm L ID, arm R ID. There are different sections in the script. This is an initialize chassis, and where you set up the elements of your car, of your vehicle, that will go in this section, initialize chassis. And here's where we would add the wheels by name. You add each of the 4 wheels. Normally we would have quotes around this, but what I did was I gave it a variable with the same thing, in case I go brain dead and type wheel RF instead of wheel FR. I can change it here, and I don't have to search through the code for maybe multiple places where I would have had the wheel defined. Once I've got it defined here as a variable, then I can just change it in one place, and everywhere it's named down here, as long as I keep this stuff right, it'll always be right. This command, this geometry equals this geometric object. That basically loads your model, the model that you've got set up in your object definition file. Then once you've loaded the model, then you can say, then you can load the joints, anything that you set up as a bone. You load it using this syntax here. SWheel ID is the variable name that I have bound above to the steering wheel. So SWheel ID equals, and you put steering wheel inside these brackets. The head ID, and then head goes in the brackets. Arm L ID, then you have arm L in the brackets. Arm R ID, arm R in the brackets. That is how you load the geometry into a joint. We're now telling the script that these are going to be used as joints. And that's all loaded in the initialize chassis function. And we actually animate it then after update frame. Now update frame reads certain inputs that are defined in this engine. And like engine is the speed, D is time that's elapsed since it last looped. Brake is whether or not brake is pressed. Steering is whether or not steering has been moved. And so all of that stuff is coming from key bindings. And so this reads your input. Each time it loops through, it reads the condition of whether you're giving it gas, whether you're giving it brake, whether you're steering. And then these are values between, I think, -1 and 1. And you can parse these values with commands, and you can make them intensified or less, depending on the weight and mass of your model. Basically, this is where you get down to the nitty-gritty and the math of making your model drive. But here's where we're going to do our animation. Somewhere after this update frame command, this syntax, this geometry rotate joint origin, and then you put the variable that you've assigned for, like in this case, the steering wheel, the head, the left arm, and the right arm. And then you give it a value. In this case, whatever the steering angle is, I want all of these things to be based on the steering angle. The steering wheel is going to turn a certain amount according to my steering input. The guy's going to turn his head to look in the direction that he's turning. And the arms are going to move to follow the steering wheel. So now the steering angle is going to be directly 1-for-1 for the steering wheel. The guy's head is going to be the steering angle divided by 2, because I only want it to move about half as much. And because the arms are long, through trial and error, I discovered that if I divide the steering angle by 4, the end of his hands will be about right if it rotates its shoulders. And this last part is the vector. So this the origin, his head is going to rotate about y-axis, which means it's the vertical axis. It's going to rotate from left to right. The arms are going to rotate about x-axis. One of them is going to go one way and the other one is going to go the other way. So I've got the one hand going opposite in x -1 and x1. This is interesting here because the vector, I don't have a good way, or there probably is a way, but I don't know how to do it in Blender, to where we can set the manipulator at the angle. So right now, the manipulator for the steering wheel is set for like 90 degrees, but the steering wheel is actually at about 14 degrees from being at a square angle. So the way you can do that is if your manipulator is set at a square angle, but the object that you want to rotate is at an angle to that, you can get the right rotation by using the sine and the cosine of the angle. So in this case, the steering wheel, it's about 14 degrees from being horizontal. And so the sine of 14 degrees is pretty close to 0.242, and the cosine of 14 degrees is pretty close to 0.970. So by plugging those values in here, that will keep the steering wheel from flopping around, rotating in a way that isn't really on the axis that the steering wheel resides on. Basically, these are the commands that are going to do the animation. And it's worth pointing out that the more I know about this, the more apparent it is that this is a highly programmable and animatable system that they've got here. You can literally take any model that you've broken into pieces and do just about anything with it. So having made these changes to accommodate the character that's in the Porsche now, let's go back to Outerra. Okay, so let's load our car into Outerra now. go to the sandbox menu, click the land vehicles, scroll down to our Porsche, click it, and then spawn. And press C to step outside the vehicle. And what I want you to notice is we've got a character inside. When we move the steering wheel, his head moves to see which direction he's going, and his hands follow the steering wheel. So basically, by creating a model that's got separate appendages, we can animate each appendage completely separately. So what we have here now is a vehicle that's very similar to the one that comes with Outerra, but now it's got a person in it that we've designed. It's completely subject to your ability to model and your ability to animate. You can do pretty much anything you want with a model that you can break into pieces and use those simple and repetitive blocks of code can be used to animate just about anything. So that's it for this this tutorial on animating characters and vehicles in Outerra. Thank you.